Geometry, Chapter 1, Section 4. This is vocabulary for this section. There are a lot of words here, but most of them, I think even all of them, you know, so they aren't like new, but we need to make sure we have a formal definition so we can use the formal definition later when we do proofs. So take a moment, pause, and copy these down. Okay, let me rearrange this here so we can talk about it. So a degree. When you're talking about a degree, if you've got a circle and you take the circle and divide it up into 360 parts, you're going to see that each one of those forms a degree. So we've got 360 degrees in a circle. And that's how we start talking about angles. So that's that part. Again, I think you've dealt with degrees before. Get that out of the way. So array, here's array. It's got an endpoint. It's got an arrow. It goes on forever. It goes on forever in one direction. So that's array. Opposite rays. If we take this ray here and this ray over here, and we put them on top of each other, and then I make them go in a line. There we go. We have opposite rays. They form a line. They have a common endpoint, and they go on forever in both directions. Okay? So that's what opposite ray just means. The two rays form together, have the same endpoint, and make up a line. An angle. An angle is non-collinear, so here we go, non-collinear, don't form a line, non-collinear, don't form a line, rays, and have a common endpoint. So this is an angle, this is an angle, here's an angle. We don't call that an angle, we call it a line. Okay, so that's angle. Sides, when you have an angle, this is a side here, and this other one over here would be a side. The two rays form the two sides of the angle, and then this endpoint that they share is called the vertex. So this is a side, here is a side, here is a vertex. So if you want to add pictures into your vocabulary, that might help you. The next part, interior. The interior part is the less than 180. So if I had a point A right here, let's make it a point. There's my point A. Connect those. Okay. Point A is now in the interior. Interior, 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 interior. All of that is interior. Out here, that would be in the exterior of the angle. Over here, oops, sorry. Over here would be the exterior. Over here would be the exterior. Here is exterior. Interior, exterior. Interior, inside. Exterior, outside. Okay, let's look at the angle now itself. We've covered inside and outside, interior and exterior. And the next one is right angle. You've covered right angle before now. Right angle, 90 degrees. So if it's at 90 degrees, it makes a right angle. If it's a right angle, the notation you will see is a little box right here. If it's got a little box right there, we know that is a right angle. The little red box means 90 degrees. Acute angle. Acute angle is anything less than 90, so even right here, that would be acute. This would be acute, this would be acute. Less than 90, acute. Obtuse, greater than 90, so somewhere over there, somewhere in here, even right in here, that is still obtuse. It is greater than 90. So you can't just go by looking at it and say, oh, that looks like 90 degrees angle. You actually are going to have to use your protractors and measure the and then an angle bisector, so I made it like 60 degrees to make it easy. And I grabbed another ray and made it at 30 degrees. Those would be this middle ray. Let me add some letters here. A, oops, need a V for vertex. Let's go G, H, and J. And put some points on there. So I've got V, I've got G, I've got H, and I've got J. So VH is a angle bisector to JVG. And I call this angle JVG. Notice the V is in the center because the V is my vertex. You put the center letter as the vertex. I could also call this angle GVJ, and those two angles are one and the same. V is still my vertex, and it's still going through points G and J. VH, so ray VH, I could write that VH is a angle bisector, like so. And then I would need to say that that's a ray, so I would put a little ray mark over top of it. So angle, or ray VH is an angle bisector. Notice the V comes first because the V is my end point, and the end of my little symbol up there and points towards the H, meaning those two H's are done forever. So ray VH is an angle bisector to whichever angle you want to call it. Let's say like that, like such. VH is an angle bisector, or ray VH is an angle bisector to angle JVG.